Okay, here I'm going to show you how to import your ASCII file into Excel and then how to graph it quickly. So you're going to have Excel open, file, you want to open or browse to the folder it's in. You may not see it because you're only going to see Excel files, so make sure you say view all files. Then you're going to go up to here, click your file that you want, say open. Here it's going to say, hey, is it delimited or not? In this case, yes, it is tab delimited, which means there's a tab between our wavelength number and our absorbance. And then we're going to start to import around cell 13, row 13, in order to get just our data. In this case, it's delimited by a tab. You can see how it's separated the two. And here we'll just hit finish, giving us our wavelength on the left and our absorbance on the right. We'll insert a cell so we can type in what it is. Right, nanometers. And then we have absorbance that are some arbitrary units. Okay. So the first thing we're going to do is we're going to go to the bottom of our data, and then we will take this all the way up to the top because it's just does not want to go. It doesn't like me today. There we go. We're going to take this Y data and we're going to do a scatter plot and plot it. And you can already see that we have some points that are very negative, and that's in the UV, and that's because the cuvette we're using is not very transmissive in the UV, and we can get a lot of artifacts this way. But we also want to make sure we go ahead and put in our X data. Okay, there's our X data. Okay. So there we go. We have the nanometers correct. I'm going to get rid of some of these grid lines. Okay. So these negative ones we're not really interested in, and we're only really interested in the spectrum itself. So we are going to edit that. Make sure our minimum bound is 350 where the data starts. Our maximum bound is where the data ends, which will be 1000. Okay. And then with our other axis, we really want to go from a minimum of 0 because we're not interested in the negative. I mean, negatives do exist. Oops, negative is 0. And our maximum we'll do is 0.6. Now you'll notice some of our data is dropped out. Well, why is that? Well, we have data over here we're not seeing because it's negative, but what's going on with the rest of it? And let's go look around 750. In reality, we're getting values that are just below 0, right? We're getting these values that are 0.01, 0.02. And so the problem here is our blank is a little bit negative, maybe because of orientation to cuvette or just some small change between putting your sample in and the blank. And that's okay. So you can adjust for this tail going out here in a couple ways. You could do it by actually showing a little bit below the line. I normally don't like doing this because it makes it look just not professional. And yeah, in reality, those are really 0. So what you can do is you can apply an upward shift to this system. And the way you do that will be making a third column, which is still your absorbance. And this cell is just going to basically be this cell plus that offset value, which is 0.02. So basically just bringing everything back to 0. So basically column C is the same thing as this, just adjust it up. So you go back here, we would say, hey, we really don't want to use that B column. Instead, for our Y value, we want to use the C column that has been slightly adjusted up to correct for that 0 offset. And ta-da, everything's been brought up just a hair, and your values are pretty much all the same, so you don't have to worry about it. Now, if this was a huge offset by a much larger number, then you may want to be concerned about it, but 0.02 really isn't enough to be concerned about. So now you have your beautiful chart. You can go ahead and add in your axis titles, right? This would be wavelength in nanometer. This would be absorbance, arbitrary units, and of course, this would be absorbance versus wavelength for the nitrite azo dye. And then, of course, you can put it into your PowerPoint talk. Another thing you might want to do on this chart is you may want to say, hey, what is my peak, or where is that peak, right? So you're going to want to find out what this maximum value is. So a good way to figure out the maximum value is something called large. Large will give us the array. I'm just going to highlight a couple of them. And I want the biggest large number. Okay, well, why did I only do that far? I don't want to drag down. I know it's going to 652, so I'm just going to drop it. So my biggest number, absorbance, is 0.53. Okay, so let's say I want to figure out where that is. I can do an index match and go to the right and determine it, or I can just do a quick if statement. If this value equals this value, which in this case I will fix with F4, then I want you to put a little line there so I can find it. Otherwise, show me nothing. And then I'll just fill that down. And then what that does is when you actually hit that peak of 0.53, as you scroll through your data, you'll see that all this area is, around where this peak is. So I would say right in the center would be my peak, which is 451 nanometers. So now on the chart, you can put a little marker here that says 451. Anyway, that's it. It's pretty easy.